A very warm welcome, my dear students. So, our today's topic is differentiation. Differentiation is widely used in physics, and therefore, you should know about differentiation and how to differentiate various different functions. So, to start with, we have to understand that differentiation is just like a mathematical operator. Just the way we have addition, subtraction, multiplication, division, same way differentiation is a mathematical operator. Generally, when we want to find out the gradient or the slope of a line, we simply do change in y with respect to change in x. So we try to find out the rate of change of y with respect to x. Now, sometimes when you are trying to measure the change in y and change in x, the change in x can be pretty small. If the change in x is very small, so that the delta x almost approaches 0, then delta y by delta x actually changes to dy by dx. So dy by dx is nothing but the rate of change of y with respect to x. This is the physical meaning of differentiation. If you want to find out the rate of change of one quantity with respect to the other, you simply differentiate quantity 1 with respect to quantity 2. On the other hand, if I want to talk about the graphical meaning for differentiation, let's say that I have my x-axis and y-axis, and I have a line here which is inclined at an angle theta. Now, if I want to find the change in y and change in x, I can simply say that tan theta is going to be delta y by delta x. But if delta y by delta x is very small, then if delta y by delta x is very small, then I can say that my tan theta is equal to dy by dx instead. So actually when we are differentiating, it is giving us the slope or the gradient of the line. That is the graphical interpretation of differentiation. So physically, differentiation means that you're taking the rate of change of one quantity with respect to another. Graphically, differentiation means that you are trying to find the slope or the gradient of the graph. You can also calculate the gradient of the graph by doing tan theta, or you differentiate y with respect to x. Now let us look at the rules for differentiation. The first one is the power rule. Suppose I want to differentiate x to the power n with respect to x. Then d by dx of x to the power n would be equal to n x to the power n minus 1. This is a direct formula which you can learn and implement wherever required. For example, let's take a question here. Let's say I want to differentiate x to the power 5 with respect to x. So d by dx of x to the power 5. Then that would be equal to 5 into x to the power 5 minus 1. So n over here is 5. I'm just substituting directly in the formula 5x to the power 5 minus 1. That gives me the answer as 5x to the power 4. Then d by dx of sin x is cos x. d by dx of cos x is sin x minus sin x. d by dx of tan x is secant square x. And d by dx of ln x. ln x is same as log x to the base e is 1 by x. See, these are direct formulae which you will have to learn the way they are. You can derive them, but we physicists don't need to derive them, right? We will just use the operators the way they are. When you differentiate cot x, you get minus cosecant square x. When you differentiate cosecant x, you get minus cosecant x cot x. On differentiating secant x, you get secant x tan x. And on differentiating a constant c, if you differentiate a constant, the answer is 0 because the value of a constant never will change. d by dx measures the change in one quantity with respect to the other, right? But the constant value never changes with respect to x, y, z, whatever. Therefore, the differentiation of a constant is always 0. If I differentiate 4 with respect to x, then the answer will be 0. Now, since we know the basic rules in here, let us try and work out some examples here. So we have the first question here, y is equal to x to the power 4. To use this or to solve this or to differentiate this expression, we simply have to remember the power rule. The power rule said that d by dx of x to the power n is equal to nx to the power n minus 1. So if I want to differentiate x to the power 4, then my n here is 4. So 4x to the power 4 minus 1, that is 3. Therefore, the differentiation or d by dx of x to the power 4 will be 4x cube. Then suppose I want to differentiate x itself, okay? Now when I just have x, that means it's to the power 1. So 1 into x to the power 1 minus 1, which is 0. Anything raised to the power 0 is 1. Therefore, the d by dx of x is just 1. You can also think of it as dx by dx is 1. Let's look at the next question. We have y equal to 3x to the power 7. Now, 3 being a constant, okay? Here the constant differentiation of course is 0, but it's not alone. It's in multiplication with x to the power 7. Therefore, whenever you have a constant that is getting multiplied by x or any other variable, then you take it out of your differentiation. So when I want to differentiate 3x to the power 7, I take 3 out of my differentiation. It's in multiplication with the derivative of x to the power 7. So 3 into d by dx of x to the power 7. Now 3 remains the way it is. X to the power 7 differentiation using power rule would be 7x to the power 6. So now 7 times 3 is 21. So 21x to the power 6 is my final answer. Let us look at another situation here. So I have y is equal to minus 4x to the power 5. Over here minus 4 is the constant. Over here minus 4 is the constant. So I take it out of differentiation and I just differentiate x to the power 5. Now the differentiation of x to the power 5 would be 5x to the power 4. So my final answer becomes minus 4 times 5, that's minus 20. So minus 20 x to the power 4. Okay, so these were some very basic examples related to the rules that we already learned. Now let us talk about the addition and subtraction in case of quantities when you want to differentiate it. So let's say I have a function y is equal to a plus b and I want to differentiate y with respect to x. Now if a and b are two functions which are also dependent on x and you want to differentiate them as a quantity on a whole, then first you differentiate a with respect to x and you differentiate b with respect to x. Since a and b have a sign of plus in between, therefore you just put the plus in between the derivative. That means dy by dx will be equal to differentiation of a with respect to x plus differentiation of b with respect to x. Similarly, if you have y equal to a minus b and you want to differentiate y, you differentiate a and b separately, but because there is a negative sign in between, therefore you subtract the differentiation of the two. So dy by dx will be equal to dA by dx minus dB by dx. Now let us pick up some examples here. So I have a question over here. We can look at y is equal to 3x cube minus 8x. So these are two quantities, 3x cube and 8x, and there is a negative sign in between. If I want to calculate the differentiation of this function, if I want to do dy by dx, then I will have to separate out the 3x cube and 8x. So I'll take 2 d by dx of 3x cube minus d by dx of 8x. Now the differentiation of 3x cube would be 9x square. So 3 you keep out, x cube you differentiate, so that would be 3 times x square. So 3 into 3 times x square. Then I subtract the derivative of 8x. The differentiation of 8x would just be 8. So therefore my final answer becomes 9x square minus 8. Similarly, let us look at another situation. I have y is equal to 8x cube plus x minus 4 and I want to differentiate this function. Let us take differentiation inside and differentiate each of these quantities separately, and in between keep the same operator as present. So I do d by dx of 8x cube plus d by dx of x minus d by dx of 4. Now the differentiation of 8x cube, if you want to do, you keep 8 out of differentiation. The differentiation of x cube would be 3x square. Differentiation of x with respect to x is just 1, and differentiation of 4 with respect to x is 0, since it is a constant. Therefore, my final answer becomes 24x square plus 1. Also, let us look at another situation below here. Y is equal to x to the power 7 minus 3x to the power 6. Now let's differentiate this. Again, to differentiate this, I will take the differentiation of x to the power 7 separately and 3x to the power 6 separately. So d by dx of x to the power 7 minus d by dx of 3x to the power 6. Now, d by dx of x to the power 7, so you know it would be 7x to the power 6 minus 3 times into 6x to the power 5, so that becomes 18x to the power 5. So my final answer is 7x to the power 6 minus 18x to the power 5. And the last one over here, we have y is equal to x to the power by 9, x to the power 9 by 3 plus x to the power 4 by 4. If I want to do dy dx of this, now again I will do the differentiation of both of these quantities separately. To do differentiation of x to the power 9 by 3, I keep 1 by 3 out and I differentiate x to the power 9. X to the power 9 differentiation would be 9x to the power 8. Then I differentiate x to the power 4 by 4. So I keep 1 by 4 out since it's a constant. Then x to the power 4 differentiation would be 4x cube. So my final answer becomes 1/3 of 9x to the power 8 plus 1/4 to the times 4x cube. Now you may cancel it, you may further simplify it, but this is the basic logic that we have to use while working with quantities or functions that are getting added or subtracted. Further, we can also talk about multiplication. Now, before doing questions, let us look at how the multiplication works, or what is the multiplication rule. Let's say there is a function y which is a multiplied by b. So there are two functions a and b getting multiplied and I want the derivative of y. If you want to do dy by dx, first you keep the second quantity, that is b, constant, and you differentiate a with respect to x. Plus, then you keep your a, the first quantity, as constant and differentiate b with respect to x. This is the multiplication formula that you will use everywhere. Keep it in mind and you directly learn the formula. Now let us apply it to a question and see how it works. We have y is equal to x cube into x minus 4. X cube is the first function and x to the power minus 4 is the second function. So first I keep x minus 4 constant and I take the derivative of x cube, plus then I keep the first function, that is x cube, constant, and I take the derivative of x to the power minus 4 over there. Now let us take the derivatives. So we have dy by dx equal to x minus 4 times the derivative of x cube would be 3x square, plus we keep the x cube the same way it is, and d by dx of x minus 4. The derivative of x would be 1 and the derivative of 4 would be 0. So my final answer comes out to be x minus 4 times 3x square plus x cube. So this is my final answer here. We can also look at another situation here just to be clear with the multiplication formula. So here I have my two functions, 1 minus 2x and 3 minus x. So first I keep the second function, that is 3 minus x, as constant, and I take the derivative of 1 minus 2x. Then I keep the first function constant, that is 1 minus 2x, as constant, and I take the derivative of 3 minus x. Now to further look in here, I have 3 minus x times the derivative of 1 minus 2x. One derivative would be 0 since it's a constant. Minus 2x derivative would be just minus 2. Plus 1 minus 2x remains the way it is. The derivative of 3 is 0 and the derivative of x with respect to x is 1. So I have 1 minus 2x multiplied by minus 1. So my final answer over here comes out to be minus 2 times 3 minus x minus 1 times 1 minus 2x. This is how we will use the multiplication rule. We keep the first function, we take the derivative of the first function by keeping the second constant, plus we do the derivative of the second function by keeping the first one as constant. Now let us look at the division rule for differentiation. So y is equal to a by b, and I want to differentiate this quantity. So the formula is very easy. You keep the numerator, like you keep the denominator constant first and take the derivative of the numerator. Then you keep the numerator constant and take the differentiation of the denominator. Subtract these two and divide by the denominator square. So I have b dA by dx minus a dB by dx by b square. Let us apply it to some examples and see how it's working. So I have y is equal to 3x cube plus 8x by 2x. So 3x cube plus 8x is my numerator and 2x is my denominator. As per the formula, first I keep 2x, my denominator, as constant and take the derivative of numerator, that is 3x cube plus 8x. Then subtract. You keep the numerator constant and you take the derivative of the denominator. So I keep 3x cube plus 8x constant and I take the derivative of 2x. This whole divided by the denominator square. The square of 2x is 4x square. Further, dy by dx becomes 2x is constant and the derivative of 3x cube would be 9x square. The derivative of 8x would just be 8. So 2x into 9x square plus 8 minus. Then I keep the 3x cube plus 8x constant and the derivative of 2x is just 2. So times it by 2 divided by 4x square. You may further simplify this, but this is the basic idea behind the quotient rule or the division rule for differentiation. We will do one more question here just to be further clear with it. So I have y is equal to x square plus 1 by x minus 3 and I want to do the differentiation of this. Again, I'll use the quotient rule. I keep the denominator, that is x minus 3 constant, and I differentiate my numerator, that is x square plus 1 minus, then I keep my numerator constant x square plus 1 and I take the derivative of my denominator, that is x minus 3, and this whole divided by x minus 3 whole square, which is the denominator square. Further, we simplify it. So x minus 3 times the derivative of x square plus 1, which is 2x, minus x square plus 1. The derivative of x minus 3 is just 1. So this whole divided by x minus 3 whole square. That is how the whole derivative idea works in there. Find derivative for the quotient rule. So you may further simplify it, you may leave it like this depending on the demand of the question. But these are the basic rules that you need to work around with differentiation. So first was simply differentiation formulae, like what is power rule, what is the differentiation of trigonometric identities like sin x, cos x, tan x, whatever. Now we have the differentiation of you have the differentiation rules like the addition, subtraction rules, the multiplication and division rules. Now finally we move on to the chain rule. Now chain rule is something which you can work directly also with, or you can take an example and understand it. So let us take an example to understand it. So I have a function y is equal to x square, and I ask you, like the question demands, that take the derivative of y with respect to t. Now when I want to take the derivative of y with respect to t, but my y is not dependent on t, y is a function of x. So how will I take the derivative of y with respect to t when it doesn't depend on t? So for that, we use a small trick over here. We multiply and divide by dx. So what I do is, I do dy by dt and I multiply this dy by dt by dx and dx. So I have dy by dx times dx by dt. By doing this, what I have done is that I can take the differentiation of my function y with respect to x and then multiply it by the differentiation of x with respect to t. So it is just a little modification over here. So dy by dx I can calculate. Dy by dx for x square would be 2x. So therefore I substitute dy by dx as 2x and I let dx by dt remain the way it is. So dy by dt is 2x dx by dt. So whatever derivative you know, you take that derivative, and the derivative that you do not know, you just let it be the way it is. So I do not know the relationship between x and t, so therefore I let it be the way it is. So I let it be dx by dt. We can also apply the chain rule to some functions where powers are involved. So sometimes we have a function like y is equal to x to the power 4 minus 3 and whole square. So over here you have to understand that the 2 power, which is outside the bracket, is an outer function, and this x4 and minus 3 is an inner function. So when you are doing differentiation, we keep it in mind that we start differentiating from the outer part. So first you differentiate the outer part and then you differentiate the inner part. To do that, what we do is that we say that this 2, like let's just assume that this x to the power 4 minus 3 is some function to the power 2. So any function raised to the power 2, if I take its derivative, it would be 2 times that function to the power 1. So 2 times x to the power 4 minus 3 to the power 1. I just differentiate using the power rule, assuming that this x to the power 4 minus 3 is just one quantity something. Then I further will have to differentiate the inner part. So first I differentiated the outer part, which was the power. Now I differentiate the inner part, which is x to the power 4 minus 3. So 2 into x to the power 4 minus 3 d by dx of x to the power 4 minus 3. Now I differentiate x to the power 4 minus 3, which simply comes out to be 4x cubed, because the differentiation of 3 would just be 0. That's how you can use chain rule, or how you can use chain rule when you're working from outer functions to inner functions, or when you have multiple functions involved, okay, or when you are trying to find out the derivative of a quantity with respect to something but they do not have a direct relationship between them, then you use the chain rule. Further, we move on to double differentiation. Now double differentiation simply means that you have a function, you take its derivative once, and then you differentiate that function again to get the second derivative. So see, when I do the first derivative, that means dy by dx means the rate of change of y with respect to x. Now if I want to differentiate this function again, let's put another d by dx in front of this function, okay. So I have replaced y with dy by dx. That means I am taking the rate of change of dy by dx with respect to x. This is what is the meaning of double derivative. You differentiated once, got an answer, and that answer you differentiate again to get the double derivative or the second derivative of the function. What meaning does it have in physics? That is what you have to understand now. Let's say that you have some function y is equal to fx. So now see, if you want to calculate velocity, velocity is simply the change in position with respect to time, okay. But if I want to find out the instantaneous velocity, then I'll have to do differentiation of position with respect to time. I do dx by dt, which will give me the rate of change of x with respect to time. Why do I need to differentiate here? I need to differentiate here because instantaneous velocity means the value of velocity at that particular instant of time. So if you want to find for a particular instant is a very small thing. Therefore you cannot do delta y by delta x, and hence you have to do dy by dx. So therefore I am taking the rate of change of position with respect to time here. So I do dx by dt. Now let's say that you want to find out instantaneous acceleration as well. For that you take the rate of change of velocity with respect to time. So you do dv by dt. Now v is dx by dt and a is dv by dt. So I can replace v with dx by dt. So I'll have my acceleration as d by dt of dx by dt, right? So that's a double derivative of position, which can be further written as that a is d square x by dt square, which further implies that all we are trying to do is we are differentiating position with respect to time twice. So I differentiate the position once with respect to time and I get velocity. Then I differentiate that velocity expression once again with respect to time and I get acceleration. Now, we will try to understand what are the applications of this in physics. How do we use differentiation in physics? For that, we have a question here. So, I have a question. A particle moves in a straight line through a fixed point O. The displacement s meters of the particle from O at a time t seconds is given by s is equal to t cube minus 5t square plus 8. Find an expression for the velocity v meters per second of the particle after t seconds. This is the A part. Now in the A part we just need to find out the velocity expression. To find the velocity expression, I have to differentiate the displacement expression with respect to time. Why am I differentiating? I am differentiating because you can see that your displacement is a function of time. It will change with respect to time. Therefore, I have to do ds by dt. So I take the differentiation of t cube minus 5t square plus 8 with respect to time, and I will get my velocity expression, which further equals to, so the differentiation of 3t to the power 3 is 3t square, 5t square is minus 5 into 2t, and 8 being a constant has a derivative of 0. Therefore, my velocity expression comes out to be 3t square minus 10t. Now look at the B part over here. The B part says find the time at which the acceleration of the particle is 20 meters per second square. To find the time, first I will have to find out the expression for acceleration. So what I can do is I take the derivative of velocity. I have the velocity function. I differentiate it with respect to time and get my acceleration. So acceleration is dv by dt, which further means it is d by dt of 3t square minus 10t. If I take the derivative of 3t square, it is 6t and 10t is just 10. So my acceleration expression comes out to be 6t minus 10. Now as per the question, acceleration is given to us as 20. So I can substitute this a as 20. So 20 is equal to 6t minus 10, which is further equal to 30 equal to 60. And from here I get my time as 5 seconds. This is how we use differentiation in physics. This is one of the typical applications of differentiation in physics. If you like the video, do subscribe to our channel. I would also be posting videos for integration and other mathematical tools that are required for physics. Do subscribe to the channel, and if you want, you can also book our live classes. The links are available in the description. Thank you.